Hey guys, today we're going to design a payment gateway. There is some resources that have covered this before. The best one that has already covered this before is Alex Shu in the payment system chapter. The other ones I think are not fantastic because they don't really highlight the Auth-capture workflow. Some other examples of like real world implementations of a payment gateway is Stripe and PayPal. Really the Auth-capture workflow is really a crucial aspect of this design. I can go into that. I'll go ahead and I think we should kind of draw that out a little bit to explain why it's such a crucial aspect of this design. I'm not really going to go into the numbers a whole lot in this in today's video because this isn't actually a really common interview question. I haven't really heard of a lot of people that are receiving it. It might actually be similar to the distributed ledger question, but I've only heard of it getting asked a couple of times. Otherwise, I have never actually heard of anyone being asked to design an actual payment gateway. It's just a really important aspect of other system designs that you'll come across, like hotel reservation. I'm actually going to use that for demonstrating why the Auth-capture workflow is such a important aspect of designing a payment gateway. So we're going to have the browser for a user booking a room or like hotel reservation system, and you're of course going to have a backend. It'll be the booking backend, the booking service, and you'll also have so we've already done our business with the listing service. This is the actual part for the booking service. So you don't really talk to the listing service. That business is done. It's something that already happened in the past. And now they've already put in their payment details, and they want to talk to the booking system, and they actually want to place their order. They want to actually pay for the hotel room. You've got your backend, you're recording the reservation in some kind of database and in your own system. So this is the reservations data store. And you'll also have a payment service. An external payment service. Oh, is there anything else on large? Okay, external payment service, for example, Stripe, and let's center that. And they're of course going to have their own database as well. Okay, so you're going to have a reservation tracked in your own systems, but there's all these external services that don't belong to your own system, where you have to actually handle the money aspect. So the issue is when you're talking to this one, and this one actually does the payment, you need it to be idempotent. You can, of course, set up retries, but if the retries aren't idempotent, the issue is that when you have a call coming into your service, let's go ahead and oh, there's that color. I want to use that for Stripes box. There we go. And then this one should just be like regular services, or we should just have it in white. Okay, so you have a call that comes into your service, and you're going to talk to the external service, which is over here. So your call comes into you, you make a call to the external service, they're supposed to send you a response, and then a response is supposed to come back from your service over to the browser. The big issue here is when you get a failure on this part right here, which means that the external service has charged the transaction, but it looks to you like it hasn't. And so the big issue with if your failure happens here, that's fine, because when you do the retry, it's not going to result in a double charge. Let's actually go ahead and walk through all 3 different scenarios for why this is so important to make it idempotent. So in this one, it's your request that fails. And then when you do, you're just going to do a retry. And so then the way that's going to look is like this. And so the first one did not actually charge the customer. And so you're fine to go ahead and make the request again. Okay, we're really going to do that. Fine. So you didn't actually charge the customer on this box. So then when you do the retry, it actually charges them. This is the really thorny scenario. And so then in that case, when you, let's just go ahead and copy that so I don't have to screw around a whole lot with the box. So in that case, when you go ahead and try to charge the customer again, they end up with a double charge. So this is how double charges happen. This is the whole big reason why it's so important to make it idempotent, is that this results in a double charge. And so how do you make it idempotent? You make a key, and you want to separate the actual charging. You want to have the actual charge occur with a key. And then when you don't have when it fails to go through, like in this case, you just send the key again, and then it's already executed, so it just returns a 200 success. And so that's what we want to do in order to implement the Auth-capture workflow, is that the first one just sets up a key in the auth flow, give an idempotency key, and then in the capture flow, you actually execute the charge given the idempotency key. So then you can't get a double charge. If you've already charged it the first time, it won't go through a second time. That's why it's so important that this Auth-capture workflow is a aspect of the payment gateway. We're going to be designing this aspect in our design. This was just kind of left as a black box when I walked through it before for the hotel reservation service. And we do not want to back down on this. I want it to be dashed. So we're going to be expanding this. We should go through how it's going to look in practice with the 2 workflows. Kind of deep dive this a little bit. So we have the reservations data store. It's also going to have the inventory data store and the hotel reservation system. It's not as crucial, but it's like, okay, this thing is going to be doing a lot of stuff. So it's that the booking service is doing so much stuff. That means that we're going to have a big opportunity for failure on the booking service. So the first thing that we're going to do is I want to first get an idempotency key from the payment service, from the payment processing service. So that one is we're going to have 1, get the key, 2, store the key, 3, charge the customer using the key, and then we want to get a success back, store the charge successful events. And then you can go ahead and decrement the inventory. You can change the ordering of these a whole lot. It's definitely easy to charge these. You might even want to do the decrement of the inventory before the charge, or like before you even get the key, because then you're going to be able to hold it. You won't have an issue with not necessarily being able to reserve the room after you charge them. So you actually probably want to decrement the inventory first, and then if you can't actually properly charge the customer, then you would go ahead and compensate. You can go ahead and do a compensating transaction and roll it all back. So there's a couple of different ways to do the whole number of steps, but you've got a whole bunch of different steps here, and the divide between the auth step and the flow step is right here. Capture step is here. And it's composed of a couple of different steps. It's that there's a lot going on in this, as you can see. So I'm thinking that you might actually want to use an orchestration component or something is probably even a good idea. Let's maybe do that. Yeah. Or no, okay, I think we're good. I think we're good. We'll not do that now. We can maybe do that at the end. So first you got a request coming in from the customer. Go ahead and decrement the inventory possibly. You can even do a similar thing with the inventory to make it an idempotent change where you set up the way you interact with this can be made similar to the payment data store over here, where you do 2 steps in order to properly reserve some space on it, and then you don't have like a double decrement of the inventory. So you can do similar things over here to what this thing will do. So decrement the inventory, get the key, store it over here. Let's go ahead and start numbering these. So we have 1, we have 2, 3, get the idempotency key. 4, we're going to go ahead and, 4, go ahead and stick it in there. And then 5, you're going to go ahead and try to properly charge the customer. And I've included the request over here on the left. So we should probably update our steps over here to make that a little bit more clear. One request comes in from the customer. Oh, we got a question. Instead of getting an idempotency key from the external payment service, we can use a booking ID as them. So you can also provide it yourself. I think that's definitely a very good call out, is that you could provide it yourself. I was thinking that it might make sense for the payment service to provide it, because then you wouldn't give them the opportunity to screw it up. I was thinking that if you're a payment service provider like Stripe, and you're providing this payment service for tens of thousands, maybe hundreds of thousands or millions of different businesses. Some of them might be really small businesses that don't have the best people that are the most talented engineers. And maybe one of those engineers is going to screw up how they set up the idempotency key. And so that's why I was thinking that it might be a good idea to have the payment service provider like Stripe provide the idempotency key for you. Also, you'd be able to use the auth step to hold the funds. So you can actually hold the funds on their card potentially, and then actually do the real transaction over to your client on the second step in the capture step. So so then you would know whether or not they actually have the money in the first step. I think that's kind of a thing. I've heard you can place a hold on a card. It's like when you go when you pay for stuff on Amazon.com or a couple of different websites, or when I've gone to the Amazon Go store, it's like I usually get charged like after I go into the store. And you might have read articles about how different things might hold hundreds of dollars on your card or something like that when you are making purchases with them. I think there was a pretty big article about that recently with, I don't remember who it was, but it was kind of surprising how much they were. Oh, gas stations. At gas stations, they actually place a hold on your card for a couple of $100 before you even start pumping. And then when you're done pumping gas, that's when they actually charge that amount on your card. So they hold like $100, and then later they only capture like $75 of it. So that's kind of what I was thinking with the idempotency key and why you would have 2 API calls. And then I was like, I think that it is reasonable to maybe that's one approach, is where you have the customer provide their own idempotency key, and then you can bring it down to 1 API call instead. if you're something as big as Stripe or PayPal, though, I don't know how much you would trust your clients with being able to implement that properly. Just like you could have a client that just gives everyone a UUID of 100 that's using their service, or just other really idiotic things like that. So I was thinking the UUID might be helpful for ensuring that your client, it's not an efficiency thing, it's a safety mechanism, as well as thinking with that. It's definitely another very that's definitely another approach that I'm a fan of, is just letting them provide their own idempotency key. Okay, anyways, one, request comes in, two, get key. Oh, I changed it so that the inventory happens first. Okay, two, it's the inventory, three, get the key, four, store the key, five, charge the customer. And then when it comes back, you're going to do the store the charge successful. And so that would be step number 6 over here. Okay, so a lot going on, and that's what I was thinking. It might even make sense to have an orchestration thing. And so the step 7, where you come back and you tell the customer, like, hey, send response to browser of success. That's what I was thinking. You probably want to make this whole thing, you might want to have it over a WebSocket or something. So that way it's a server-side event, because the whole fit process could be like a minute. I know when I book a hotel, usually there's like a little spinning wheel while it's handling that. I don't think it would be synchronous to handle the payments. And so then when you're doing things asynchronously, I can go ahead and show what this would look like if we had an orchestration component in it. Is that then we're going to have, let's have something that looks similarly to this little box, and we'll call it orchestration components. And an example of that is AWS step functions. I think this is the most popular way to do orchestration, is AWS step functions. If you're within Amazon, there's actually a thing called Herd that's really popular. It's like at least as popular as AWS step functions over within the retail org. And you would actually you would kick off a thing, and let's go ahead and move all of this. And this talking is actually going to happen through the orchestration component. And actually the talking to the payment service would even happen over that as well. So let's move it like that. And then we have this over here. And I kind of like how this looks a lot more than the other. And it's mainly because of the interactions with the booking service, which you'll see here in a minute. And we talked to the inventory service. So the first thing that's going to happen after 1 is that we're going to have the first request come in, and then you're going to have a quick return of a 200 success. And so that'll happen pretty quick. And so you won't have a really low latency response going back to the browser. So we could even draw that first arrow back over here, kind of like this. So we have a pretty quick one there, and then it's 7's going to happen over the WebSocket. 7's going to happen over the WebSocket. I could maybe explore that idea of having your own provided idempotency key later on in the video before the end. I don't think that's how you would want to do it with Stripe, but I definitely want to cover that as well. When I was thinking through how to do this like an hour ago, I was thinking like, you could totally cut out a whole call here by just providing your own key. I don't know why they don't do that. And I was like, oh, well, what if they do it wrong? Could you potentially even do malicious stuff? And I'm thinking that there's an opportunity for at least doing it bad. There's definitely an opportunity for the client shooting themselves in the foot. And so doing it as a safety mechanism, I guess it makes sense. Anyways, you got the first one, it goes to here, and it just says, okay, we've got it. We've kicked off the workflow. We'll send you another call here way later on. And then that'll do the server side push with the WebSocket. So you're probably also going to want to have, this is going to be stateful, and there's probably going to be something for handling that call. You would have the orchestration would make a call back to this service. It would be driven by the orchestration component making the call to the booking service. So you would probably want to pass in the IP address or the connection ID from the booking service to the orchestration component here with the first step. And then okay, I can go ahead and label this 1, 2, 3, 4, and then asynchronously you're going to have this other flow where this thing actually starts doing its workflow. You're just saying, hey, message received, I'm going to do this thing. And then it's going to actually start doing all of this. And so then you would have 5, and then it does 6, 7, you capture it with 8. No, you capture, so this is the idempotency key, capture it next, and then you actually try to charge it, and then you store whether or not that was successful over here on 9. And then after it's successful, it's like, okay, we've properly gotten it. Now let's go ahead and tell the customer that it went through properly, and then you can have that push over here as 11. So I'd use an orchestration component just because you're going to probably have so many retries. There's such a high potential for retries. That's why I'm thinking there should be an orchestration component. And it should, when you have such a high opportunity for retries and how much time that's going to add to your requests, it makes sense to make that all happen asynchronously. And so we have this kicked off as the first flow, the first request and response flow. Then all this other stuff can happen with a whole bunch of different retries. And so that's, yeah. Let's go ahead and separate the capture and auth steps. That is a little bit easier to see what's going on here. Yeah, I'm going to go ahead and copy paste this twice, and we're just going to dive directly into the auth flow and the capture flow. And actually, we're going to have first is just kicking off the workflow itself. And so I have that up here is just kicking off the workflow itself. And so that's not even the auth step, that's just the workflow going on. And then here we have the capture step. Okay, so here we have the auth step, and then we're going to have the capture step. So we have the capture step. Okay, and so we've already kicked off the workflow, and now we're talking about the workflow itself, going ahead and doing the auth step. Okay, yeah, it's fine. See ya. It'll be recorded. Okay, so we have the auth step, which is well, inventory is technically not even part of the auth step. Let's go ahead and ignore that. So we would first have the idempotency key, and then let's store the idempotency key. So that's the auth step. And then we have the capture step. And we'll have that over here. And so this is what the capture step looks like, is you run the charge and then you store the result. And you would just have a bunch of retries on this. And those are idempotent, so then you don't have the issue with double charges that we showed up. No, this is the double charge scenario. Let's probably label that. We have the double charge scenario. And then this one is the request failure scenario. double charge. That's from the response failing. This one's from the request failing. Okay. We should talk about the DB schemas next, but this definitely breaks down how the request response flow works. You have a reservation record and say reservation UID. You'll have your own UUID independently of the payments. You would have user ID, building ID, just other stuff like that related to your own system. But you would also want to have the charge ID just for the external payment service. So you're storing what comes off of this. So we're going to have the response contract, some kind of charge ID. And that's what we really care about. Say it is GH CDEF 789. Okay, and that is what we're going to store in our database. Then you have the next step in your workflow, which is where you're actually going to use that step. So then in this case, it's actually the response that's going to be passing in charge ID. And the first one is just a GET request. And pass in payment details. Something like that. Amount that you want to charge. Should be a string. Okay. Getting the charge ID, you store the charge ID, and then the capture step, you given the capture, the charge ID that you had in your reservations data store, you're going to run it through the request, and then you would just get like a 200 success back for. So, and then the way it would look in that bad scenario, double charge failure scenario, the way that happens is you would get a 404, for example, and so it actually successfully ran it, but so in this case, this interaction with the database was successful, but you get a 404 failure because the packet was just dropped over the network or something like that. But you can just go ahead and keep retrying with that until it is successful. Okay, external payment data store. So we can go ahead and make this a bit more of a white box implementation. Right now, it's a lot more of a black box implementation of how the payment service provider will work with its own data store. Let's maybe emphasize the auth step and capture step before we get into that, is to just kind of, that's just kind of like important stuff we produced so far. Okay, and then we should go ahead and do, let's copy these two and expand them in the white box implementation. So we have the black box implementation right now for the auth step and capture step, where it's more from the perspective of our booking service. But I want to talk about these two steps more from the scenario of more from the perspective of the payment service provider. And so we're going to do a white box implementation. Okay, so we have this, and I guess it doesn't even have to talk to anything external. It's so we're gonna have another box that would look like, oh, let's duplicate this. This would be Visa or MasterCard or something like that. So we're Stripe. I want to copy this. We're doing a white box implementation, so that's why I want this to look like that. Then we could even say these are now external services when you're talking from its perspective. There would be a connection over here, but I think in this first step, you just want to have that UUID in your schema. You don't really, all we really need in the schema right now is just the information we've been provided so far. It's the card number. We need the amount. So we don't want to be asking for it a second time in the auth step. And we're going to record our own charge ID. We would have, let's have a UUID generating service. I don't like to deep dive the implementation details of that. So that's like a whole question of its own. So we're gonna have our own UUID generator service. So we're gonna have, oh, come on now. So we have the request come in, and then we're going to get our UUID from our generator service. I receive that back to, it could just be like a daemon process, background process that's running on the same thing. The UUID generator doesn't have to be its own service. This is just the easiest way to think about it conceptually. And then we're going to go ahead and write that UUID. There's not going to be any direct interaction with Visa or MasterCard yet. I think we want to store the charge ID that we have just generated. So that's all the information that we need so far. And we would have our response in number 4. No interaction with Visa. It's the capture step where we're going to do that. We don't even have any interaction with the UUID generator here. So let's delete these. Replace them with what we just made. Don't need this either. There's no interaction occurring with our UUID generator, so I'm just going to use a regular straight line, not directional, it's just a connected component. Have the request coming in for that step. We have the last contract. Okay, the request comes in, and then we're going to go ahead and actually do our interactions with external payment service. I feel like they would just talk to each other exactly similarly to how the booking service components would talk to Stripe. And so it can similarly just do its own orchestration thing when talking to Visa. Or I'd imagine they would trust each other more. They might trust each other more than Stripe trusts its clients. So then you could possibly just use your own UUID for that. Have a within network call. I think you would store, oh, let's add a status. Of pending charged, probably better choice for that. So you actually execute it, and then you would want to update your status that you've properly done that. You should, so if you're going to do retries, you should, of course, store the UUID that you're going to be doing your retries with. So you would have like the Visa UUID in here. You'd store that before you do the calls with it. Then with your retries, it would be idempotent. So this one is created in the second step. It comes back. Okay. Let's line these up each other and clean up what we've done a little bit so far. We got the black box implementation of the payment service provider over here. On the left with those diagrams. And no, we want to have no fill. And then we have the white box implementation on the right. Stick that over here. And the hell did that come from? We just delete it. That's the double charge scenario. And then over here was kind of like the first step of in the black box implementation. Stick the double charge scenario over here. This was the whole flow end to end of the black box implementation. Okay, and then we had step 1 and then step 2 and 3. And let's go over here. Those up. Okay, so we have the white box, we have the white box implementation, we have the black box implementation. We've gone through the 3 different flows that are happening here. I guess we haven't fully labeled what's going on in the capture step in the black box implementation. Oh, we did go through it over there. Yeah, I do want to walk through that. So 6 and 7 came out to 1 and 2 over here, and then we want to talk about 8, 9, and 10. So we have step 8 is the request and response there. 9. The last thing that's going to happen is over here. I'm going to add more arrows for what's going on here. Have 1 is the request there. And step 2 is here. 3 is updating our reservations data store. Then we get a response back. Step 4. Five is talking back to the booking service. We don't need these other arrows anymore. So it is actually going to talk back to, it's going to actually be making a call to booking service, not the other direction. And then you'll get a response back up to 100 OK. Booking service is stateful, and it will actually that should be 6. And then we have 7 over here. Okay, so talk to Stripe, record the result from Stripe, send the response back to the browser. You could also have a notification service in here for emailing the client in addition to that ping back. So that's usually something that happens with hotel reservations is you have a notification service. We don't need to go into that though. We can have that if we revisit the hotel reservation service problem. We want to focus more on the payment service provider in this video. I didn't fully label this. Yeah. Okay. 1, 2. Three, 4. No, you're not talking to browser for that. Okay, yeah, it's just getting the UUID and storing it. And then in this step, you're actually doing the charge of it. Okay, we fully walked through the Auth-capture step and the black box implementation. I think we covered it all in the white box. Or you're not including that in it. You need to store it in the database though. Didn't go through that. For 5, and then 6 is the response back over here. So you generate the UUID, you record it, you return it back to the client, and then they can use it over here. 1, 2, 3, 2. Okay, so bring back the charge ID. You have the Visa UUID, or you could even just use your own UUID, I guess. Yeah, we can just use our own charge ID, I guess. Anyways, we would want to get that out of the external payment source. That's what 2 is the get. It's a read. Then you do that and then update the status. That's everything we need. Okay, and I didn't really want to go through capacity estimations on this problem because it's not a common legitimate interview question, and the numbers used in a lot of the other attempts that people have taken at it are usually so low that it's like they're just trying to cop out of trying to make it scale. I just assumed 1 billion payments per day, which comes out to 10,000 per second. So you probably want to shard it. And that means we're going to be using NoSQL databases. So you could use DynamoDB with strong read consistency. Or if you could even just manually shard. I feel like some of these are probably going to be doing manually sharded PostgreSQL. Strong read consistency. I feel like that means that your write operations could clobber each other. In our case, the UUIDs should minimize the risk of that since it's going to be different records, but manually sharded PostgreSQL, I feel like a lot of them are going to be using that. Within Visa or within Stripe, they're probably going to be just manually sharding their own PostgreSQL instances, which is going to be a pain in the ass, but I'd not be surprised at all if they're doing that. I think this is all that I actually wanted to cover on this problem. Okay, so whole flow end to end of the black box implementation. Here's what happens with the double charge scenario. Here's a happy path for the request failure scenario if it's non-idempotent. Here's the double charge scenario with the spams. We have the black box implementation of the payment service provider. Yeah, so that was first we did, hey, kick off the workflow and tell the customer about it, do the auth step, do the capture step, and then we looked at how it would actually look within Stripe over here on the white box implementation. I'm pretty happy with this. I'll of course put the diagram over in the Discord channel, and the recordings, of course, going up on YouTube. Yeah, I don't really know what else I wanted to. I'd want to deep dive on this. I'm pretty happy with it. Thanks for watching, guys. I'll see you next week. Yeah, happy Thanksgiving. See ya.